So in this video, we're going to take a look at how to study and represent games using Python. And the particular Python library we're going to use is called Nashpy. So first we need to install it. And to do that, we just type pip install Nashpy. And you can do this at a terminal window if you're on a Mac or on Linux. Or if you're on Windows, I definitely recommend getting the Anaconda Python distribution, and then you can do this in Anaconda prompt. So I press enter, and that's installed. And now what I'm going to do is, here's my Jupyter notebook window, and I'm going to create a new notebook. And I'm just going to call this notebook representing normal form games. So first things first, let's import Nashpy, and the import is with the library is called Nash. And now just to confirm the version of Nashpy that we're using in this video and subsequent videos, it's 0.011. Now, Nashpy is a library for studying two-player games, and so we need to obtain we need to input what are called payoff matrices for both of our players. And so I'm just going to record those as A and B. Now, the game we're going to look at is a game called the Battle of the Sexes, and I'll explain the utilities after having created the game. So we have 3-1 and 0-2. So this is in essence a matrix where the first row is 3-1 and the second row is 0-2. And then I've got another matrix B, which is 2-1 and 0-3. And then I create my game by going Battle of the Sexes equals Nash dot game, and I pass it A, B. And once I've done that, we can take a look at Battle of the Sexes. Let me see, it's a bi-matrix game with payoff matrices given below. So the row player has payoffs 3-1-0-2, and the column player has payoffs 2-1-0-3. Now, the way a normal form game works is that the row player essentially controls which row we're in, and the column player controls which column we're in. And following that, the utilities are read off by their respective payoff matrices. So the Battle of the Sexes, the story behind is you have two players, and they would both like to go and see a particular movie or something like that. So we say, for example, that the role player would like to watch a sports movie, and that would be the first option. So the first column is a sports movie, and the column player would like to go see a comedy, and that would be their second row or the second column. But fundamentally, both players would like to go together. So if they both choose their first option, the first row and the first column, then the row player is going to see the movie they wanted to see, and they get a 3, and the column player is going to see not the movie they wanted to see, but at least they're with the row player, so they get a 2. If, for example, the row player chooses their second option, so the comedy, but remember the row player preferred the sports movie, and the column player chooses their first column, then they both get 0, because here they're not going to see the same movie, and they're going to see the movie they don't like. Now, what game theory allows us to do, and what Nashpy will allow us to do, is kind of study this a bit more and obtain what's called Nash equilibria, but we're making our way towards that. Another notion is that we might have a different game. So there's a game called Matching Pennies, and this game has the following utilities: 1, -1, -1, and 1, and B equals essentially the opposite of this. So -1, 1, and 1, -1. And this is called Matching Pennies. And so we just create it in the exact same way. And now note the immediate difference is Nashpy is telling us that the first game, the Battle of the Sexes game, is a bi-matrix game, whereas Matching Pennies is a zero-sum game. And a zero-sum game simply means that if you add both matrices together, you get 0. So the gain of one player is the loss of another. And so we can we can create a zero-sum game in a different way. So we can just go matching pennies equals Nash.game and pass it a single matrix. And when we do that, Nashpy automatically knows that you want to create a zero-sum game. So that's just another little thing. And what we're going to start to see is how to use Nashpy to study various things in game theory.